chat room. We will ask the questions after the presentation. So we will first read the questions that are posted in the chat room, and then later on we can open up the discussion openly and freely to everybody. So again, I will start presenting and sharing about the project that we are soon finalizing. So the S-HVET project started 2 years ago, so we are in the final stages. This is an Erasmus Plus project where we had a goal to deliver a new joint qualification of a level 5 in the expert in building automation. So this is probably, as you all know, this is a very hot topic. This is very much in line with the many European regulatory frameworks, guidelines, recommendations. This is also something that you do regardless of this, because this basically also increases your comfort and potentially saves a lot of money on your energy bills. So besides creating this joint program where 3 countries are participating, so Croatia, Slovenia, and Italy, and they will be actually deploying this program, and they will increase and encourage mobility of both teachers or learners and workers or students participating in this joint program. The entire consortium and the partnership of this project, I can probably already say it's a successful project, was led by the Craft College in Zagreb, participated also by the University of Zagreb. The Slovenian partners are Regional Chamber of Craft and Small Businesses from Krško, School Center Novo Mesto, and Institute of Republic of Slovenia for Vocational Education and Training. And we have 2 partners from Italy, ECIPA and Centofol. We also have associated partners, so these are vocational educational agencies, which were our partners in defining and actually validating the new curriculums, which were created for building automation experts of level 5. So very briefly, I'm not gonna torture you with everything that we did and how we got to this point, but this is in general the methodology that we followed. So in the first step on your left-hand side, you can see this was a quantitative analysis. So all these things basically mean that we did not just do it out of the blue, sit around the table and define the joint curriculum. We consulted the national experts, the national employers, so the people who will actually employ and work with these new educational skilled people. They gave us their guidelines, they gave us their opinion, what do they need and what's the requirement on the labor market, how do they see the market develop, and how do they see the development in the need of these building automation skills. This was a very interesting process because we needed to find a middle ground between a superstar that of course every employer is looking for and something that we can actually do within this framework. And I have to say this was a very fruitful collaboration. This led to actually expert groups who, based on these inputs, created the curriculum. We also agreed on the joint part. So every country creates its own national curriculum defined by a large number of practical hours and a smaller share of in-class hours. But we also developed a joint part. So the joint part is defined as that which will be in a unified way organized, held, and taught in each of the 3 countries which are partners in the project. This also implied that this joint part needs to be recognized in every of the 3 partnering countries. So there was a recognition and accreditation of this knowledge. And finally, not to leave it as a piece of paper, we started, actually we are in the final stages of this piloting and setting up a sustainable cooperation structure. So putting on workshops for trainers and educators who are actually going to perform and teach this level 5 of building automation expert. a little bit about what the joint educational program is. So definitely, when you say something like this, it is not entirely clear. Are you going to have a fully exact and point-to-point same program in each country, which would be the same on, let's say, the left side of your screen? Or will you just find, let's say, a bilateral collaboration where there's a mutual agreement and some parts of educational program overlap? And to create a really good joint educational program where, I don't know, probably some of you already participated in some kind of exchanges or know people who participated in some kind of exchanges, it's always difficult when you need to find something which is an equivalent. So you don't have really a joint educational program, but you have an exchange program, and you're trying to find an equivalent to have it validated by your home educational institution. What we tried to do during this project was to actually not put our students into this position, but to actually go to this left side of the screen. So a real joint educational program. Before we go to the presentation of our speakers, I would just like to give you the key messages from our project. So in the end of the project, we are offering a specialist innovative curriculum, which in the end should increase employability of students. So this is something for students who are finishing level 4, so high school, or it's an upgrade of the students who are attending a level 5, so a 2-year program. This program was created by including experts from all countries, but also was consulted and discussed with the potential employees of these students. So the program has a high level of practical and future employer-oriented curriculum in it. A very important strategy actually is supporting our project. So there's less than a month, this strategy is out, the renovation wave strategy, which actually foresees a large pickup in renovating older buildings and is defining requirements for renovating and automating new buildings, and is actually foreseeing hundreds of thousands of new jobs, which will be required by this area of building renovation. So, not to take too much of your time and bug you with the project, I'd like to move on to what we have scheduled for today and have on our plate for today. So as you can see, we have 3 speakers here. So the first one will go Leonidas Paterakis. Leonidas is active in the field of digital design with a special attention of parametric computational design and digital fabrication. As a freelance architect, he's collaborating with several companies related to digital production through techniques as 3D printing and CNC milling. He taught at the European Institute for Design in Venice, and since 2011, he's been teaching at the postgrad Masters in Digital Architecture at the IUAV University of Venice. He's the co-founder of FabLab Venice, digital technical director and main instructor. He's also an authorized Rhino trainer and McNeil Rhino 3D and Grasshopper. Leonidas, I'd like to ask you to start sharing your screen and your presentation. I don't think I need to give you any specific additional role, that you can just start sharing it.
Hello, everyone. I'm trying also to activate my video. Okay. Hello, everyone. So just a second, and sorry. So thank you, Tomislav. Yes, I'm the co-founder of FabLab Venezia, which is a facility actually that a laboratory open to everyone to experiment and try to optimize new ways of using 3D printing or other digital fabrication technologies, from the shorter scale to the bigger scale. I will just start straightforward to the main idea of what we actually going to see. I will have many slides, but a lot of photos, so hopefully I will run through them very fastly. And actually, yes, the 3D printing is somehow the main actor, main let's say attractor in terms of digital fabrication lately. But of course, the digital fabrication, the CNC technologies are already present in fabrication, in the fabrication process of buildings. Of course, one important element of using machines is give them, feed them with data, you know, and feed them with coordinates, or at least like how the machines should be moving, no? So optimizing the algorithms and the parametric modeling, you know, the way that actually they need to act and form and fabricate actually the elements is very, very important. Just a couple of slides in terms of numbers. The digital fabrication in the building industry, mostly related to the 3D printing, is estimated right now, no, at least from 10 years from now, that will be more or less like $40 billion worldwide. The nice thing is that the usage of concrete probably will be optimized, and since it's a form of deposition of material, only the strictly necessary will be used. And they are estimating 70% of the needed quantity less of concrete using 3D printing technologies with form optimization. So optimizing the paths of the machines, but also the shape of the final output. This, of course, can be translated also in terms of cost of concrete, not only in terms of less material used, but in many cases the fact that there are no molds anymore, the whole process of doing fast and effectively and precisely the manufacturers is very important. One thing that I would like absolutely to share with you is this Gartner curve. It's actually 2 years ago. It's dated July 2018, and it's all the curve of the expectations in terms of technology, you know? And this is related to the 3D printing. So we have from 3D printing of consumable personal products initially, until to 3D printing in automotive industry. As you can see, the curve is very steep in the beginning, and then you have the valley of disillusion, the through of disillusionment. You can see that in the bottom line, and then of course the plateau of productivity on the last part. This means actually that when a technology comes out, everybody thinks it's a solution of everything, no? At least in the sector. And of course, we need time. Time will actually give us the effective usage and how the application will be perfect. The macro 3D printing, which would be the buildings and huge structures, is actually almost on the peak of the high expectations. So what we will see probably is somehow lack of interest in some months, maybe years, we don't know. And but we will sure it's sure that we'll have a position in the industry of 3D printing industry in the manufacturing process of buildings. Okay, I will just go directly to the examples because already I'm in 5 minutes of speech. I will just run through from some examples. There are many of them, and I try to extrapolate the most important. Of course, we're talking about deposition of material. In most of the cases, it's concrete. And one of the first elements that we saw in the news is this company in China that actually burned everyone in timing and came out with the first 3D printed house. But in the same time, the technique was pretty easy to imagine, no? So the sections were made flat, and then with a lot of labor, they were stacked one left to the other. Although this, even though it was an easy technique, led to a couple of years ago, the 3D printed offices in Dubai that were all made it in this way, but then formally it came out that they could be a little bit more efficient, let's say, no? Another project is, for example, Icon and Igor, and they did this project with this huge machine that actually prints and deposits concrete, and they managed to do a series of houses in Mexico, in Austin, for people that didn't afford a house. The nice thing is, in fact, of course, the social impact that this technology could have. And of course, sorry about this, it's a YouTube video implemented. And of course, you can see it's a very raw finishing, and everybody that is talking about the very fast 3D printing or whatever. It's actually very, how would you say, a very, how could we say that it's just a marketing, let's say, statement, mostly because, of course, the building is not only made by walls, but it's made out of slabs, windows, electric fittings, and so much technology that every modern houses have. So yeah, I mean, the time of the position is one thing, building a house is another thing. This is another project that has one thing in common with both of the projects behind that were anticipated, that all of them, this is a Danish project, all of them use a very big machine, a machine that is bigger than the house itself. The technique is actually the same, like we have like deposition of concrete or other kind of materials. In this case, they are building a residential building in Germany. Sorry, oh, there had to be another slide there of the construction site. But in this case also, the machine needs to be bigger than the house. Although, of course, this is obvious. In this case, we have another kind of example from Massimiliano Locatelli and partners, and partners with Italcementi, Arup, for the Milano Design Week in 2018, where the optimization of form already has a certain importance, and also the way of building is not anymore made out of a huge machine, but out of a robotic arm. So you can see the elements were like made in blocks, and of course the paths were optimized, highly optimized, in order to achieve as much as speed as possible in terms of centimeters and in height. No? Okay. Okay, this was the wrong slide from the other side. You can see around this house the whole machine that actually is rising and printing layer by layer. Another system that is been we can see actually is this fast brick robotics from Australia, and it's actually it's a robot that lays bricks on the side. There's a small video also where we can see actually the truck has a feeding element, feeding part that actually gets the bricks through the main arm that actually arrives until to the final point of deposition, and then a robotic arm that is actually correcting its position in real time, lays out with high precision the bricks. Of course, this is also an additive manufacturing technique as 3D printing, although we don't have a liquid, no, like concrete or something else to lay down. It's somehow like a Lego bricks that actually are laid down, computer numerically controlled, let's say. So these were some elements that actually have something in common. They pursue the building houses, no? Although I think the best thing to see now is that experiments, like elements that actually go beyond something that can be like laying down bricks or just following traditional paths of a plan of a house, and see what can be done better, or at least how can we implement these technologies in a higher level, no? So this is a demonstration project by Skidmore, Owings and Merrill for Oak Ridge National Laboratory in the States, that is actually made out of a smaller printer, and it's actually depositing, in this case, composites. I think it's a thermoplastic with carbon fibers or something like this. And they made these sections that then were pre-assembled to make this shelter that is able to produce energy for the electric vehicle in remote areas, in the national parks, for example, in the States, etc. So somehow it's an emergency shelter and a vehicle recharger. Another interesting project is this one, which is in Amsterdam, and it's from MX3D, from Joris Lavron Lab, and Arup ABB, and Natural Militar for the steel. It's made out of stainless steel, and the technique is to use robots that deposit in high precision in actually 3 dimensions, not just on flat going up in the z-axis, but actually evolve it and actually made it in 3 dimensions and evolve the whole structure. You can see, in fact, that the yielding is made on site. The interesting thing is that they used, in fact, 4 robotic arms that were working simultaneously. The other thing is that it's a very highly optimized structure. So these are the stress lines that have been somehow reduced and made them optimized for like printing, and so the form finding actually managed to eliminate a lot of material and optimize the final form. The interesting thing about this is that the first idea that was to make this kind of production of elements is that actually the robots would be moving together with the construction part. It's for sure this is somehow the future, but in this case the bridge was made it wasn't made on site. It was made in a shelter and then was brought to the place. Another very important, interesting example is this one, the Future Tree by Gramash and Kohler in research in Zurich. That actually what they used is this 3D printer on the left to make a mold out of 3D printed thermoplastic, and then what they did is on the right you see that it's they made the steel armor, and then they actually use it as concrete. Use the concrete as a mold. No, the funny thing is, of course, that they use the heat gun to tear up the thermoplastics. But the interesting thing is that the fusion between the 3D printed thermoplastic elements, concrete as using it as a concrete mold, and then using also timber and the precision that a robot can give us in terms of the final result, and have this kind of structures. What I want to somehow underline here is that the usage of digital techniques, of course, can give us the possibility to replace human labor, which is not something very nice. But the good thing, probably the correct way to use it is not to substitute traditional techniques, but to fuse them together in order to, in the cases that actually we need something that needs to be made in a certain way. Something like, in fact, from, I don't know, probably like a formally specific or very, from a point of view of efficiency, to have like a better, let's say, a result, output. Of course, other elements, these are some columns that actually always at the age of Zurich, Master Advanced Studies did fabrication in architecture. They did by tracing dancers' movements for a festival. Yes, Switzerland probably can afford this way of doing, but it's an interesting thing in terms of as an experiment. And then, of course, the deposition, for example, of bricks that we saw earlier could make sense if the form needs to be in a certain way. I mean, in this case, we have the computer, robot system, and the Labyrinth that came out that is actually controlled and has a form that is difficult to represent in terms even in a drawing. No, so you have like three-dimensional movements on the vertical axis that needs to be highly controlled. So this is the only way that actually can be used. The interesting thing is, of course, that even always in 3D printing, we can have examples like this. So smaller elements, each element is different from one to the other, and can be printed, and all the elements can be printed in a facility and then brought on site and assembled. No, of course, this is a quite as a pictorial or aesthetic result, but it can be translated as a relation of apertures or not of the holes related to the exposure of the sun or other climatic criteria in order to optimize the form. The same idea, of course, in this case is somehow it has this idea. It's always by emerging object. This is a private client in Beijing. I will just run a little bit because I wanted to show you the last part, which is more important. These are more terracotta deposition, and then of course cooked in an oven and made custom-made bricks. Earthquake-proof column, so optimized elements that can be without any glue or without any help, that they interlock and they are seismically effective. Other elements like using 3D printing as the cast, as before we saw with the thermoplastic before, using shells that actually are three-dimensional and very tiny, but at the end they produce a very highly strength optimized structure, or even use it as a media in order to fill it up with other materials, like from concrete to insulation. And I will just stop by here in this project here, that is interesting because it somehow pushes the boundary of how this technique can be implemented. It prints on a curved already curved surface. So sorry. So this is actually, you see, the robot follows the three-dimensional path of the shape that was already there, and is optimized in order to make the shape. So these are somehow interesting perspectives of how the thing could be evolved. This is another option with thermoplastics, but the same technique. You can see the deposition is made in a certain way, and then this chair is made on a 3D on a third-dimensional plane that actually is getting used to redeposit these curvatures in order also to strengthen the layers that actually are only in one direction. The last thing that I want to show you is our work, which is related to biomaterials and deposition of, let's say, not concrete, is the hard way actually. So using natural fibers, clay, earth materials, or biocomposites that actually can arrive and have a more efficient in terms of ecologic impact, you know, as a structure. Because the concrete, of course, we know, even if we reduce, of course, 70% of the use of concrete is a good thing, but if we can eliminate it, is even a better thing. These are some projects from IAC in Barcelona that use the same technique. but we are related to Wasp, which is this company from Italy, from Massa Lombarda near Imola, in Bologna. And these are the first experiments where we were there and helping them out on depositing. You can see the machine that they produced was actually bigger than the house. It could only do like 3 meters of diameter of this small shell. It had many problems, but it was much hardcore as an approach. So it was just like clay and natural fibers like hay bales, and it was really hard to strengthen every layer before that another layer could come up. So it took a lot of time to make this wall that you see in the left. But then, of course, the research came a little bit more. It evolved, and Wasp produced this new machine that actually, you can see it's in the center and goes circularly. And of course, you can see also on the deposition part that can be used to fill with other other elements in terms of to produce more mass and make it more thermally efficient. Even the waves on the surface can be optimized in terms of how much shadow can produce in order to make the house more efficient in terms of heating. And you can see, in fact, the whole optimization that came out. In their project, their machine actually can work by itself or with combination of others in terms of how the production can be done. Of course, it's a modular machine that can be then disassembled and managed to make it, to get it out of the place. And this year, of course, with the COVID, they had some how could you say, drawbacks, but they are doing it now. And this is another shelter that is being built now with Mario Cucinella architects, engineers from Milan Engineering, Mappei for the materials, etc. And they did with the same approach of having the possibility of using like the most natural material. And this will be the result, the final result. Of course, aesthetically, the layers become something very important. This came out actually from also our approach of having, sorry, I will just go directly here, of having also the possibility to create a parametric model of optimizing the form, but also the needs of who could use this house, use this shelter. So the idea is actually from also by Wasp is to make this huge park with the possibility of printing. In our case, the approach was similar to a previous one in order to make elements that actually are made by smaller machines and create somehow a system with igloo kind of like principles and assembled on site. So I think I can stop now. It's already half an hour that I'm talking, and yeah, thank you, and we'll talk later with questions and answers.
Tomislav, are you there? Can you hear me?
Hi.
Tomislav?
Can you hear me now?
Yes.
All right. So I've been forbidden to unmute myself to write any questions in the chat. So basically, I was helpless. Sorry about that, everyone. Thank you for Leonidas for an excellent presentation. For me personally, it was very interesting because this is not my area expertise, so it's something new that I hear and that I've learned during your presentation. I would like, since we took a bit of time from the next presentation, I would just like to move forward to the presentation of Dani Kajtaz. Dani is a system integrator in the company AVIR, California, USA, with 15 years of experience. His responsibilities are implementation and integration of home automation systems, from small single room control over the television set and audio systems to large scale home automations, which controls include multi-room audio and video control, heating and air conditioning, lighting systems, security systems, pool and spa control, door phone integration, and so on. Other skills include network setup, PBX telephone system programming, and day-to-day tech support in the field technicians that are part of our company. AVIR is a factory authorized and trained designer and installer on the finest audio, home theater, lighting control, motorized shading, network, and home automation equipment in Southern California. Notable automation companies and company works with us with and uses their products for seamless integration are Creston Control 4 and Savant, as well as package networking for hardwired connections and Ruckus networks for wireless setup. I hope Dani can actually hear us and that he can share his presentation.
I can hear you. Let me.
Yeah, we can.
Yep, I can hear you. I hope you can see my video now.
Yeah, perfect, perfect.
And then I'll start with the.
And I'll mute my microphone.
That's good.
Julia and Simona, please leave my mic available to me so I can unmute myself.
Okay. Hi, everybody. How are you today? I'll start here with sharing my screen. I hope everybody can see it. I don't have a pretty presentation like Leonidas, but I'll do my best to explain what I do in Southern California with AVIR. 1 second, please. Okay. So the company I work with, we deal with pretty much luxury installations. The places that I grew up in, there's quite a bit of clubs that have big homes, and people like to have, as you can see, scrolling on my screen here, hopefully from our website, home theaters, big automation systems. We also do commercial, as you can see here coming up. This was a big clubhouse for a golf club, which includes different sporting events, mainly golf, obviously, but as well as tennis. And what we do is we start with building a project, what the client would like to see in this system, we coordinate with an architect, obviously with different other trades as well, to integrate everything into one single system that can be controlled. I'll go ahead and start with a bit of an explanation of how these things happen, obviously starting with the architectural view of a home and a project that we do get, and how we lay out, let's say, speaker sets throughout the house, pre-wire the home for network connections, pre-wire the homes, you know, for integration of the TV locations, the music zones, and obviously security systems as far as all the window contacts, door closures, and so on. This is a PDF file of a home. I'll do a bit of, it's a big file, so I'll try to zoom in and kind of show you. As you can see here, it's a layout of a home, and then per each room, we have where the speaker locations are. So starting here in the master bedroom, you have the outdoor sitting areas. There's a media room in this home, courtyard when you walk into the house, and everything is pretty much laid out structurally. So when we go in to do a pre-wire on the fresh building, then we know where to lay out everything, or speaker rings, where the speakers will go, network connections, low voltage power, and everything that needs to be controlled in that aspect. We also do a layout of networking, which in this case, everybody today uses Wi-Fi, and not, you know, a lot of it is wirelessly controlled. So the next layout is our wireless network coverage of the same home, and you can see we have 5 access points throughout the house that should cover this entire home. Now, the next step in this process would be line drawings. It basically tells us where everything needs to be connected. Let me zoom in here so you can see. These are multiple cable boxes that are in this home. This is a video distribution system. So what that means is we have, in this case, let's see, we have about 10 sources, which means there's cable boxes, there's an Apple TV, a couple of Apple TVs. So what can happen is, in this particular home, a client can choose from any location that we have a television set in. If we had 10 televisions, they can watch any of these sources on any of the TVs in the house, meaning, let's say you were in the living room of your home, you were watching, you know, a show like Game of Thrones, and you wanted to go to your master bedroom, go to sleep, but you wanted to continue watching that same show, you can choose that same cable box and transfer it over to your master bedroom without any issues. What happens here is we have a equipment rack where all the equipment is stored in. This would go into a video distribution system. And this particular one is called Just Add Power. All the sources get connected there, and it is basically ran off of a network switch. Everything is network. There's everything runs off of either a Cat 5e or a Cat 6, and it runs through a network switch. And this one here is a what do we have here? We have a, looks like a 50-port PoE switch that powers up all the endpoints, which are the locations right here. So each one of these endpoints, it's a small box that goes behind a television set, and it goes in with a network cable and out with an HDMI cable into the television itself. So you can have a handheld remote and choose any particular source, run it on your television without, you know, having to have multiple wires going or any kind of cabling. Single Cat 5 is enough to actually give you a 4K picture on your TV. How that looks kind of in a real world, we also have here, which is one of our propositions, dimensions of mounts. Sorry, let me go back up to the top of the page. You can see we have per each room, we'll specify what kind of speakers the room will have, size of the TV itself, Next step will be installation, what the height, width, and depth of the TV is, how we would like to have it hung on the wall. It could be a recessed wall, which means the TV will be flush with the wall itself. And to make things easier for us in the installation, we usually use these wall mounts that can be pulled out. So you can pull out the TV, push it back in, and it's very easy to service later on, or make changes if so. And to continue with this, these are the specifications of what this particular installation has, size of the speakers and everything like that, that the installer needs to know, as well as the builder of the home, so we can look, specifically say where each one of these devices will be located. This is a rack drawing. This is basically the what we call a equipment rack, which is usually stored in either in the head end in a specific location, so it's out of the way of the homeowner, and everything gets all the wiring and everything gets connected to it for purposes of viewing, like an audio video receiver, an amplifier for sound, Blu-ray player on Apple TV, power management, and so on. These are just some more of the drawings of what specifically needs to happen in our installation. Air cooling and so on. The next file that I have here, which will be interesting later on for everybody to view, is the home theaters, something more of what we don't see on every day. Some of the homes that we do installs at, people do like to have a home theater. It's kind of like going to a actual theater itself, which is but much nicer. This specific file is a drawing of how the screen needs to be set up, how far from the screen the projector needs to be, and then for optimal sound, obviously for each row of seating where the person will sit to get the best experience possible. As you can see right here, this is a layout for one of our clients, and the speakers from the side, as well as the screen itself, the seating, and the distance of the projector itself. The installations of the speakers and the drywall, screen, and the soundproofing as well, so you get the best, obviously the best sound possible coming off of the speakers that they use. Okay, let me close this here. I'll go more into detail here. Let's see here. There's some of the pictures that we have done. This is a in-wall touch panel which controls pretty much the whole home. This is a big residence, a big install. So on this screen, you would see control over the house itself, from music system, HVAC, climate control, lighting, shades, pool, security, and so on. I'll actually, hopefully you can see my Windows side of the screen. I'll just do this real quick and show you what that looks like. So this is what I do. I would take all the aspects of our house, and then this is just like the picture I just showed you a second ago, which is the in-wall panel. This is what I deal with on day-to-day basis. This is how I program and integrate these homes. This is a Crestron system, and this is their software that you basically design a touch panel layout in. All of these buttons have a function. In particular, this would be the main page here. As you can see on top, you can select any of these with the finger touch. You can select any of the, how would I say it, actions for music, climate, lighting, and so on. This was a demo house, so with the demo button, if I press that button, the whole home will come on. About 7 television sets will come on, go to a certain source, and start playing music in the house, so they can show the house and to potential buyers. I opened up the climate page. I can show you what has to happen here. from heating, cooling, you know, auto. You can change the set points. I can schedule, and then in this particular home, we have multiple thermostats, which are not located in each room. They're located in a head end area, so they're away from the client. They don't have to mess with them. What each room does have is a remote temperature sensor, and which senses you know, the temperature, and then accordingly changes what the thermostat needs to do. How this works is, this is just a face of the system. What happens in the back end is actually this detailed here. This is what I have to write. It really isn't coding, let's say, like a language that you have to write. It's more of a logic system you're putting together. There are digital, analog, and serial signals. Digital are the execution signals. Analog are the numbers. They're, you know, giving me information back to me what is happening. And then the serial is more used in the metadata. Like if you were listening to music, so you can see what the next song is, you know, the album cover, and then also reading of any kind of text. What I have to do in order to make something happen in particular would be like under, here we will do HVAC. There are multiple thermostats in this home. Each thermostat is controlled. As you can see, it's just a lot of different data that goes in. And then that connects to the touch panel right here. And all of these, I'll go like this real quick. As I was talking about climate control. So all the button presses that happen on this panel, like let's say you wanted to do heat, cool, or auto, I have to tie in these numbers. These are digital joins. So I have to tie these numbers into the touch panel control itself here. And whatever you press, this program on the panel, this program then, you know, translates it back and tells all the other systems in the house what to do. In this particular case, this is actually live right now. This is a home that I've finished, and it is a demo house. So we are controlling this home in California at the moment, and I'll just go through the pages so you can see what happens when these buttons are pressed. So music system itself, the music is currently off. I'm not going to turn it on because I'm not sure if anybody's at the house. It is a demo house. By selecting the family room, I can select Sonos music, and music will start playing in that room. You can slide this volume slider here, left to right, to turn the volume up and down. I can also control all the volumes on this page here as well. As far as climate goes, again, this is at the moment, the house is on cool. Temperatures are in Fahrenheit, so now you can see that. And then I can choose any other room in the home if I wanted to, or I can slide my slider and choose, let's say, master bedroom, and you can see that being set as well. Lighting, same thing, multiple rooms. Any of these buttons will turn on lights in the house. Same goes with the shades. Shades actually, you know, actuate up and down, stop, very kind of straightforward. And then pool and spa control. Turn on the pool, you know, pool lights, and get the pools to start heating, and like things like that. So everything is integrated together instead of having to have what we kind of have today with multiple applications on a, let's say, in your telephone. You know, one application to turn your lights on, one application to start your music, one application to change your temperature at home. Everything is integrated into one system for ease of use. And what I try to do is make it as few steps as possible. If you start having a system that you have to press so many times to get to something, it gets a little bit annoying. So let me close this so that I'm turning it on. I'll go back to some of the pictures so you can see what happens in the real life. So this is the touch panel I was just talking about. Next picture is one of the smaller equipment racks. Just the way we kind of wire things, everything that is located in one location, from a router standpoint, a couple of Sonos connects, and, you know, power distribution. This is just a small system. In the house itself, what happens is usually we have these what we call equipment cans. They're boxes in a drywall where all the wiring happens. And this particular is of a DirecTV satellite system with multiple satellite boxes throughout the house. So everything is ran and cleanly designed out of sight, you know, for the client and for customers, so they don't have to mess around with any of this. They don't see it. This is just seamlessly working in their house. And this particular house, as you can see, is a pretty big system. And these equipment racks are more than 2.5 meters high. And in this home, you can see there's multiple satellite boxes. They're just for each room or however many rooms they wanted to. This is a distribution system here, video and audio. And up to, I believe in this one is 48 music zones and I believe 24 video zones. And everything is controlled by this processor right here. All the data, all the connections, everything that happens, you know, from turning on the lights, everything in this whole home is done from one processor that calculates and makes all the changes and everything. Some of the more pictures of the racks, as you can see, audio video receivers, power, there's a telephone system as well. Everything is in one spot. It's easy to work on, obviously, as long as the installer who is making the connections makes it look clean like this, so you can, there's no wires running everywhere. The cool factor of what I do is being able to go on site and enjoy seeing different types of equipment, different things that happen day-to-day basis, from small systems, you know, some new small TV to a size like this of a home theater that you don't see every day. Different speaker sets, different installations. This is here a video wall that was a curved video wall installed with panels, and you can see here the kind of the finished product. House was still being worked on, and then what we just did, which is super cool, it's a new Sony crystal LED. This is a one of the first of its kind in the United States that we just installed. A customer of ours wanted to build a home theater, and this is what he envisioned. So these are 40 panels. There are, I believe, 40 centimeters by 40 centimeters. I'm not 100% sure, but the back of this video wall is each panel is only connected by a shielded Cat6, and it goes from the top to bottom, and then from the bottom to a single video processor. So it's pretty cool installation. Again, not a lot of wiring like it used to be. So you're basically using one shielded cable to run and power. And then basically it all goes into a control box, and that's pretty much it. And you get this big, expensive screen. And this is the finished product of that same theater. So it's kind of coming to an end with the chairs being installed, all controlled power, and some pretty nice stuff to see. Another cool thing we did was this C-Seed, which is a screen that comes out of the ground, opens up, and then you get to view while you going for a swim. You can watch this massive screen out of your backyard. And I did find a video of it right here. I'll play it real quick. It's not too long. Let me turn this down, make sure it's not too loud. So as you can see, it's a kind of a, it's a cool factor. It's a fun job to do. Technology changes on a daily basis, so it's always something interesting that I get to work with. It's not, even though sometimes it's kind of repetitive and the same, but you get to be part of different things you don't see every day, for sure. So it's not too long here. I'll let you see this. It's kind of a cool thing. And the clients we do work for, obviously they have a lot of money, so they can afford all these cool toys. Anyway, so yeah, it's an interesting business to be in. The programs that we do integrate, the companies that we work with are one of the biggest ones is the Crestron, and out of New Jersey. They have been at the forefront of automation for many years, doing different kinds of things, from home automation to commercial to now doing a lot of let's say commercial in the sense of universities. They have one of the first ones to integrate Zoom as what we're using now into their touch panels, so you can have a full integrated Zoom rooms system. It's just a couple of pieces of equipment. We do use them obviously for video distribution. They have made a great strides in video distribution systems where you can have up to, I would say, 40 plus television sets just running throughout a home, and just to be able to view everything, and it all runs on a network switch, which is pretty cool. Another one of those is the Control 4. They also have different automation settings that are much easier to integrate. It's kind of a drag and drop system, where you basically just connect everything in their software, and then you get this type of a layout on your screen, and you can control again, same automation settings, and like you do with Crestron. And the last one we do use is Savant, which is another company heavily used in the United States, and I've seen it here in Croatia as well. Same with Control 4. You can, the same thing, you have your remote, everything is integrated, from your TV, HVAC, and so on and so forth. You can create scenes, you can have it voice control, you can tell it to, turn on your lights, you don't have to even, by voice, turn on your, if you want to turn on your cooking stove, or anything you can imagine. That solutions are endless. In this industry, it just seems like every couple of months something new comes out. Let me see here what else we have.
Dani, can we
yeah.
close to finalize with your finals?
Sure. I was just about to. I'm kind of running out of material. Anyways, what I wanted to say, it's an interesting industry to be in. I've worked with Tomislav last year on this curriculum involving level 5, and I've shared my thoughts. I finished high school. I learned all of this stuff by going to courses, hands-on. I did not complete my college, but there are possibilities of getting involved in a lot of this industry, and it's a great connection, obviously, between level 4 and level 6, I believe, is what we've spoke about. And I would say that this concludes my presentation. I hope it was enjoyable. So thank you all for listening to me and watching. I'm glad to take any questions you have and the other presentations. Thank you.
Thank you, Johnny. It was a very impressive presentation. As always, every time you show all these things, it's making me a bit jealous because I don't live in one of those houses. So makes me wish I do. For the third presentation, and my apologies for stepping a bit on time, but both presentations were just very interesting, and I felt a bit guilty if I was to cut them short for those 5 or 10 minutes the guys stepped up. But the last one, but not least, and probably someone who's more present and you've heard of them, especially in the region, is Siemens, and the presenter is Igor Kulašič, coming from Siemens, Slovenia. Igor Kulašič is the head of smart infrastructure in Siemens Slovenia, providing solutions in the field of building technologies and energy management. And he is the head of the business unit of building products for Slovenia, Bosnia and Herzegovina, Montenegro, Croatia, and Serbia. He works with customers and partners to create ecosystems that intuitively respond to human needs and helps customers make better use of the resources. Igor, can you hear us?
Yes, I can hear you. Can you hear me?
Yes.
Good.
Excellently.
So you can see me also, I see.
Yeah, yeah.
Good.
Would you like to share something?
Yes, I will share, but let me find, because I never used Zoom until now. I hope you can see my presentation.
Yes, yes, perfect.
Okay, great. So I will speak a little bit about the topic of smart building and smart grids, because I think that those two categories are becoming more and more connected. But first, why we shall talk about this? So there are, some global mega trends which are displayed here, and we as a humankind, if we do not do something about this, we will have problems. I mean, the whole world will have problems, and luckily we have now tools and technologies how we can handle it. I will not go in details but just few statistics information which could be interesting for you. So we expect in 2050 to have more than 10 billion people. So you can see this crowded is not what you can see nowadays because of our pandemic, but it will come again very soon. So on the other hand, we will face really high consumption of electricity. So there is somehow estimation about that the electricity consumption will double until 2050, and of course also 50% of it should be done by renewable technologies, which will bring many different challenges to the technology. And of course, majority of population will live in cities. We somehow see that today approximately 50% of people are already in urban areas, but we expect in 2050 that there will be 70% of those 10 billion. So it will be really high pressure on the utilities and municipalities. And of course, at the end, the consumption of buildings from primary energy is 36, in some analysis, even 40%. So the impact is huge if we talk from the building point of view. But before coming to the building, just maybe a few sentences about the energy system. So in the past, and still in majority today, the energy system is quite simple. So you have primary production site, and there you get energy distributed to the consumption, to the houses, to the buildings. But nowadays, of course, there are many technology coming, like photovoltaics, wind, also some battery storage, e-mobility, etc. So the systems is becoming more and more complex, and the same is happening with buildings. So we already saw in presentation which was held before that the systems in the building are becoming more and more connected and managed by the management station, and there are many different systems coming in the buildings. So the complexity of the building infrastructure is really very high. And of course, if you want to manage it, you have to have tools, you have to have possibilities to do that. So actually, building is a part of this urban area which I was talking about, and all these energy topics. So you can imagine how difficult it will become to handle all these things and how complex it will become. And actually, without some change, we don't have an answer how to do that. So as I said, we are lucky because the technology already came out. So we have this connectivity, we have cloud solutions, we have common language for all those equipment. And also the pandemic, which is today somehow boost the digitalization in all fields. And I would like to mention a few words about digitalization in the construction industry. The fact is that the middle or the center of digitalization is BIM. I assume that majority of you have heard about it. So it's building information modeling. It's kind of digital tool to plan and project the building. Why? So here is interesting graph which shows that in last 100 years, of course the graph is not so long, but construction really did not change much. And if we compare with industry, for example, you can see that the efficiency of production went up, almost doubled. So it's a little bit more than 60%. And also some other areas like services increased and so, but construction actually did not change the efficiency of the construction industry. So there is something to be done, because as we saw, there will be a high pressure on different kind of categories. And the only way how we do that, how we can do that, to increase this efficiency, is that we have to implement the digitalization. And that means that we have to use tools like in the industry, you know, before you make a product, you develop the digital twin of it, and then you check all details, design, then you also plan the production, resources which you need, and then you just do it. And in construction, that means that we have to build everything first in digital way, and then from that you go and build it up. And interesting is that the construction business is going this direction of the industry, but on the other hand, industry today is going to the construction, because at the end you have production which is very individualized. For example, a car, you can pick up the things which you like to have, and the production industry can follow your individual needs. And the construction business coming from the other side, from the individual needs to be able to be produced efficient and digital. So if we talk a lot about BIM a little bit, it's not only about the 2 or 3D drawings, but there is also schedule, the time schedule, where you can much easier to plan all needed resources. Of course, you can also collect the costs, the cash flow, for example, the time frame. And of course, at the end, with 6D, you can also manage the building with the tool. So and of course, at the end, you can also go further when you have to remove the building. It can be also used with this approach. So coming from here, as I said, we have this digital twin, and after that we build, and then we manage the building. And of course, at the end, we can also take it out. What is important that the 80% of the whole costs of the building are in the life cycle when you use it. Only 20% the building represents the costs to build it up. So this is why really the biggest impact on that challenges which we have from the energy consumption and also the complexity of the management, it's really important that you use efficiently the building. And to do that, you have to use these tools. And to do that, you have to have guys who are capable to do it. So this kind of study which is going on now, it's really one of the most I would say, prosperial know-how. Yeah. So if we look how the building is going today, so we have planning phase and construction starts, and then you align during the planning, but at the end nobody really knows what he will get at the end because of this. You know, you're changing the plan, the projects, you change equipment during the building, then you order too much, you're late. And so actually with digitalization, you really get transparency, you really get the more possibilities to plan efficiency, also the construction side. So on the other hand, also you know, during the today, when you build up the building, you lose a lot of information. So, you know, you have a planner architect, then you have mechanical planning phase, electrical, and you lose information in between. When you implement digitalization, you don't lose any information, and there is much more efficiency also from that point of view. So you see also the complexity. We have to change also the way how we work. So the cooperation becomes the most, collaboration becomes most important topic. So, and also this multidisciplinary know-how, it's important. Yeah. So when we talk about smart building portfolio elements, it includes everything from the comfort point of view, like building automation, HVAC, lighting, mechanical, electrical, and also we can put here also these audio and video systems, entertainment part. Yeah. So on the other hand, there is also safety, like fire security, video surveillance, intrusion control, access control, smart spaces, like you would like to track where are the tracks, asset tracking, when predictive maintenance, and of course the energy efficiency, which I mentioned several times, asset efficiency, as I said, and of course this connectivity to the grid, that the building is a part of the urban infrastructure, because buildings will be equipped more and less also with their own energy generation stuff, and then you will be able also to trade. When you want, you can trade it, sell it, or you can use it, or you can, however, be more flexible. And this is how we see that things will go, and we provide also from that point of view the system, we call it the SIGO-CC, which can integrate all these kind of categories inside, and also it's communicated with the infrastructure from the energy management. And this is why in Siemens we established this smart infrastructure, which includes smart grids and smart buildings. And we believe that with that, we can handle the challenges which are in front of us, and we can assure safe and comfort for all of us. Let's don't forget that more than 19% of our life we spend in buildings. The most important things which happened are in the buildings. So we were born in the buildings, majority, I think. We studied, we married, we raised the kids. Yeah. So we make love, and so I think this is very important. Yeah. So that's from my side. I hope I was not too late, too long. Yeah.
No, Igor, that was perfect, and you actually made up on some time that the other speakers probably took from you. I would really like to thank you for the presentation. Just to mention that University of Zagreb FAIR had a project where we automated our faculty building. It was a large project, so there was other buildings involved, so also HEP building, where Siemens was the partner. So the technology that Igor was just presenting is actually a part of the living lab at the faculty, and we actually see this thing work operationally on an everyday scale. So I am a bit familiar with the technology and what you have to offer. So we are a long-term partner with Siemens Croatia. We enjoy working with them. So, all right, thank you. We have come to the Q&A part. I know that I have said that if anyone has questions, they can post them on the chat. Unfortunately, in the meantime, we've learned that the chat does not work. So the fundamental idea is will not work. Therefore, I would just like to ask you, I'll do my best to moderate it and to make it one by one, but I'd like to ask you to just turn on your mic and ask a question if you have for anyone from the project consortium, but more preferably for our speakers, because I think they all gave very interesting, practical, and different view presentations on the future of building automation. So I leave the floor open to the audience. Okay, maybe I can break the ice with a couple of questions. So I'll go one by one. Well, if it's okay, I'll start from Igor because he was the last one to present. So we have, Igor, if I can ask you just to comment a bit on a building at FAIR. So we had, let's say, an inherited system which was installed there before. It was semi-automated. It was not centrally controlled. So it was something that was installed at a certain point, but this was not a building automation. Can you maybe comment or give your view on when you have a completely new building to be automated versus something which is you're going on an existing site with something which is inherited, and you need to basically come up with a custom-made solution for a customer. Just give us some comparison, and maybe can you comment when you're on site and when you're actually doing this, does this impact much the comfort or does it intrude the life or the work of the occupants of the building, and how much in your experience?
So first of all, of course, it's easier when you build up new building because you plan in that kind of usage. But I have to say that today systems are really, really very flexible. So you can, you know, with new systems, for example, our total room automation system is that kind of structure that you can afterwards also open space, you can make an offices, you just reprogram the stuff. On the other hand, also the existing buildings, if they are refurbished, it's not so complex at the end because there are many systems which are capable to communicate. So with our system, we have many integration possibilities. So we integrate almost all standard communication protocols like BACnet, Connex, DALI, LON, etc. On the other hand, also some different kind of integration is possible, which can be more hardwired. For example, you put inside direct inputs, outputs, and of course, at the end, you have always possibility to change the system. You know, if you have a system for example, for fire safety, which is 30 years old, still using that radioactive sensors, it makes sense to think about to change it because it's at the end, it's life security issue. And of course, when you change this kind of system, you have to rewire usually. So that means there is a little bit of let's say, break of existing, but you can always do it phase by phase. So you don't need to empty the whole building. You can do it phase by phase. So actually we have all kind of experiences from new buildings and also of refurbishment. The old one, I have to put out that we have also many radio systems. So for example, if we refurbish some old museum or a library or something, we have systems where you don't need to put cables. And everything is secured, cybersecurity, you know, issues very important for Siemens. Everything is also tested with all needed certificates, etc. So, you know, if you work with player like Siemens, then you as an end customer can be quite safe from that point of view also.
Yeah, thank you. I'm going to continue with something that you mentioned, and it stuck to me when Johnny was presenting. So the biggest difference that I saw was you presenting something that's automated and coordinated with the entire system, which goes very well hand in hand with some smart grid or smart systems of the future, electricity systems, but the energy systems as well. So on the other hand, Johnny, you were presenting something which is more, let's say, exclusivity. So it is not so much about saving energy or being responsible or coordinating with the system. It's more about being luxurious and using the technology to make your life nicer and better. And the controls that you were showing were more like there's a central controller and you can set some things manually, control things. You control things from that point. Is there an option on, or do you integrate these options into your installations where you actually have a possibility of automating these controls? So let's say some kind of if-else controls or something more advanced.
There definitely is. I mean, even as far as even as far as ecological, we do that. The companies that we do work with are coming out with products, obviously, to save on on energy and power, and then how things are integrated. The area that these homes are built in is an area where there is constant sunlight. So a lot of these homes do have sun power or solar power that are being fed to the house. So the electricity is basically being recovered. Or sun, being reused in a sense. I'm not sure if I can still hear me, but so as far as the if and else and then statements, and if something happens, there can be different things programmed in a sense of lighting control. If it's a certain time period of the day, have your lights come on steadily in the house, or
probably.
Lights turn off, shading, like you said, even music if you wanted to. I mean, the possibilities are endless. We can create something as a macro or a a scene, to a sense, what a client would prefer, by even activating them by voice, or just by pressing the button. Music, TVs come on, or pool starts to heat. I mean, a waterfall, fireplace, and anything is really, really possible to do. And as far as the kind of green power, we do have a lot of monitoring equipment we use now. Should something go offline, it sends us an email right away. We can troubleshoot the system from remote. As you know, I'm in Zagreb at the moment, so even with this pandemic, I've been actually having more work than I've had before, and I don't have to be physically in the United States as I went this last winter. So I can do all of my work I can do from sitting at home and on my computer, other than being, if I had to do something any kind of other physical connection, myself. But
thank you. So my last question would go to Leonidas, and this is more like a soft question because this is not my area expertise, but your presentation was interesting to me because it sort of made me think. You presented more of applying 3D printing for new buildings, new constructions, and let's say building homes of the future, or things like that. Have you ever seen an example, or do you see these being used in refurbishing or reparation or renovation of the existing building stocks? So of course, there's a potential in quick building of the new homes, but let's say there's a big thing in Europe now where there's a lot of buildings that need renovation. And for example, in Zagreb, we have a quite unusual situation from March this year, where the city center was struck by earthquake, and now it needs to be renovated. And there's a sort of a push that this renovation needs to go towards smarter or zero emission buildings or low carbon buildings, so that you actually make the old city core, which is mostly inefficient and not green, to be more environmentally friendly and less energy consuming. So did you ever see the technology that you presented being used in, let's say, such an application?
I totally agree that it's an emergency on not building new, but refurbishing, and especially in Europe, where the consumption of soil is very, very very important, no? No, for now, they are not, at least from my experience, that there's not yet an application on the like using 3D printing or computer-based techniques on refurbish or repairing or doing something like this. But of course, it's possible. Like in the near future, will totally be an option, especially combining them with real-time controlling, like scanning, or even scanning in sense of revealing what's the problem in a depth of a wall or whatever, and of course having robots, or at least a computerized method of intervening and solving specific problems. Of course, I think that in this case the biggest problem is that every building is different. In many cases, at least in Italy, when we're talking about refurbishing buildings, especially historic buildings, there are a lot of problems in terms of it's not problems, but actually it's a need of also preserving a certain way of refurbishing. So I think for now, at least, the human labor will still be in the game, let's say.
Yeah, dominant in doing these things.
Yeah.
Yeah. Thank you. I like the answer. It's very much in line with how I would think about it. Did anyone from the audience bring up courage to ask any questions? Are you interested in something from these three speakers?
Well, I am wondering how steel is added when you are using printing technologies for buildings, because you need to have stiffness when you are building, let's say, a building from concrete.
Well, the thing is that the 3D printing is, at least for how in a large scale, how the applications are made, is to combine steel and 3D printing and concrete that is deposited. So it's not like a machine that autonomously does the work. Of course, it does part of the work, but in the same time, less people, okay, combine, for example, steel bars or other elements, or in many cases there are people that actually work directly with the material, reinforcing the concrete with fibers and making it more stiff and more important. One key element, for example, in terms of the static, let's say, approval for now is, in fact, that there's not a unified code of calculating these kind of structures, no? Because in fact they are cutting edge, so they are still in the middle between like a wow effect application and a concrete in sense of real application, no? So until there's this lack of regulation, no, we still have this issue of making 3D printing buildings but even items, like large scale items that actually are guaranteed and perfectly functional. Hope it was enough as an answer.
Yeah, but thank you for the answer. I thought to myself that some issues need still to be solved, so that the technology is still being developed.
Yes, definitely. But it has some elements, some characteristics that make this technology transmit enthusiasm. Let's say that somehow it's quite new. It's very different, and in the same time, okay. Let's say that the founder of the FabLab movement, which is Neil Gershenfeld from the MIT in Boston, once said that actually this fabrication generally, it's more or less like the microwave oven. When it came out, everybody thought it was like the solution about everything, but at the end, it's just a complementary tool. So it's not that we need to forget everything that has been done until now. It's just a new tool that can give more possibilities, but when the traditional methods are more efficient, we just need to use them.
Thank you, Leonidas. Do we have any other questions from the audience? We are slightly over time. This does not mean that I discourage you from asking questions, just to make it one more and perhaps end up the discussion if someone wants to ask something. All right, if not, I have two things to ask you. The first one is I'm launching the poll. I hope you all can see it. And this one is very relevant for us. So I'm asking you to actually complete it. I see that already more than half of you have, or around half of you have filled the poll. This is something that we ask you as a favor for our project. It's very relevant that we demonstrate that the quality of what we do is at the level of satisfactory level for the European Commission. And while you are finalizing these answers and these polls, this is gonna take you just like 1 minute or 2 minutes. I would really like to thank our speakers, because not only that they took time from their work to be here and to present us these things. I think all three of them have presented something which seems a bit futuristic, but it's actually happening now. And they have shown, I think, in their presentations that there's so many interesting things that are being developed that are potential for the future students, where they can work on what they can learn. And I'm really hoping that all the students and PhD students or whoever was attending this presentation is now very interested in this topic and is thinking about looking more into details of what our three speakers have presented. So Leonidas, Dani, and Igor, really thank you for your time and for an excellent composition of your presentation. It was very inspiring. Let me just check. So we are at 37 out of 67. So please, the remaining 30, if you can finalize this, we would be really grateful. It's not opening. Okay, the remaining can finalize the poll. I think for the rest of us, we can start moving to the end of this round table. I hope you all enjoyed. I hope the speakers are happy to have joined and spent some time with us to give us their view on the building automation and the potential of building automation in Europe and especially the region. And Dani for giving us a slight insight what you can do in the States if you have a lot of money, which is something very inspiring, both from the technical side, but from what you want to do if you earn money. So definitely Dani has a solution for you. And I'm very happy that we stuck more or less to the time. So thank you, everybody. And if there's no more comments or questions, I would like to end this roundtable. All right. Goodbye, everyone.
Thank you. Goodbye.
Goodbye, everyone.
Bye.
Bye. Thank you.
Thanks to all the students from Slovenia. Bye.
Goodbye.